Hi class, in this video we're going to learn how to build the simple linear regression model. As we've discussed in the previous video, the purpose of simple linear regression is to model the relationship of the two variables x and y in a mathematical equation. We've also looked at the simple linear regression equation, which is y hat equals to a plus bx. So imagine I have a scatter plot here. Okay, there are many lines that could be drawn through the scatter diagram. For example, this line here, okay, or this line here, or even this line here. The procedure that we will be using in our simple linear regression model is called the least squares method, and it helps us find a line that best fits your set of data. What I mean by the line that best fits your set of data is, now imagine this is the line that best fits the set of this data. This is our simple linear regression line. Alright, so the least squares method ensures that the distance from the simple linear regression line to your actual data is minimized. Alright, so this distance, the summation of all of the distance from the actual data to the regression line is minimized. And this is the method of least squares to minimize that distance. And again, our estimated regression model would be y hat equals to a plus bx. The estimated regression model comes from the population regression line, where the complete model would be y equals to capital A plus capital BX plus the error term. This is the slope and the y-intercept. The lowercase a is simply the estimated value of the y-intercept, and the lowercase b is the estimated value of the slope. Besides finding the model that best fits our set of data, the reason we would use the simple linear regression model would be because the estimated value of the slope here gives us the change in y due to a change of 1 unit in x. So we could actually evaluate the magnitude of change in the dependent variable due to the change in the independent variable using the regression line. Furthermore, the estimated value of the y-intercept here, the lowercase a, helps us predict the value of the dependent variable when the value of the independent variable is equals to 0. And here we have the formula that helps us calculate the values of the estimated y-intercept and also the estimated slope, which helps us model the least squares regression line. And these values are again provided in your final exam. If you could see here, to get the estimated value of the slope, or b, we simply use the sum of squares of xy divided by the sum of squares of xx, which we have actually previously calculated in your correlation coefficient, and similar to the values of x bar and y bar. So let's try out your past year final exam question, the continuation of the question. The question says, find the least squares linear regression line for the data. That means we need to calculate the values of b and a. So as previously discussed, the value of p is simply sum of squares of xy divided by sum of squares of xx. Based on our previous results, the value is 388 divided by 2150, which gives us 0.1805. So in order to find the value of A, we need to find x bar, which is the summation of x, 220 divided by n, which is 8. And this gives us 27.5. Also, we need to find the value of y bar, which is the summation of y, 38, divided by n, which gives us 4.75. So in order to find the value of the estimated y-intercept, we use this formula here, y bar minus b x bar. So A would be y bar minus b x bar. And this gives us negative 0.2127. And so the estimated linear regression line would be y hat equals to a plus bx. So the value of a is negative 0.2127 plus b would be 0.1805x. So the estimated model must be written in order to get the full marks. And so the line that best fits the scatter plot for this data would be this line here, okay, which could be drawn by hand or by a computer software. And you only draw this line when the question asks you to do so. And because this question did not ask for the line to be drawn, we simply do not draw the line. I hope this is clear for all of you. Okay, let's go to the next question. Predict the scale reading at density 45 gram over centimeter cube. If you still remember, the density is the independent variable and the scale reading is the dependent variable. So you are asked to predict the scale reading when the density is 45 gram over centimeter cube. So let's use the linear regression model or the linear regression line to predict the value of y hat. Previously, we got the value y hat is equals to negative 0.2127 plus 0.1805x. And so when the value of x is 45, the value of y would be 7.9098. So the value of the scale reading is 7.9098 when the density is 45 gram over centimeter cube. Okay, that's it, class. We have learned how to find the simple linear regression model or the line that best fits our set of data. We have also learned how to estimate the value of the dependent variable when we are given the value of an independent variable. And I'll see you in the next video then.